Welcome everyone, I'm Adam. In this problem, for our given vectors, say u equal to negative 2 times I plus 4 times j, where I and j are unit vectors, and v equal to 3 times I plus 2 times j plus 5 times k, we're going to be finding the cross product, u cross v cross u, and then v cross v. So before we get started, let's review what our cross product is and how we do it. So a cross product, say u cross v, we're using our determinant form of our formula. Okay. So the determinant form says, again, not a true determinant, but we set up this kind of 3 by 3 matrix where our top row is I, j, and k, and then we list in the components, where our second row is the components of u, u1, u2, u3, and the third row is the components of v, v1, v2, v3. And then again, starting at the top with I, covering up that column, and of course across the top row, taking just that 2 by 2 matrix that is left and taking the individual determinants of that, which is where we get u2, u3, v2, v3, right here times I. And we repeat that process, covering up the column of j, getting our u1, u3, v1, v3, taking the determinant of that times j, and covering up the column of k, getting our u1, u2, v1, v2, the determinant of that times k. So looks kind of daunting to start with, but once you do this enough, the process becomes pretty simple, and you pick up on it pretty straightforward. So let's go ahead and get started. We're going to find u cross v for part A. So first we need the components of u and v. So looking at our u up here, so this is equal to negative 2i plus 4j. Since there's no k component, we can interpret that as plus 0 times k. So 0 times k. So this gives us our u1, u2, and u3. And of course, v, we have our v1, v2, and v3. So how we're going to start with our u cross v is setting up this first initial matrix, or the determinant thereof. So this is equal to, and our matrix I, j, k, and the next row will be our components of u, negative 2, 4, and 0, and the last row components of v, 3, 2, and 5. Okay, and so now, covering up the I column, we're going to take the determinant of the little 2 by 2 matrix that's left, if we want to consider it that, with entries 4, 0, 2, and 5, times the component vector I, minus the determinant covering up our j column, leaving us with negative 2, 0, 3, and 5, times our component vector j, and plus determinant covering up the last column, giving us negative 2 and 4, and 3 and positive 2, times our component vector k. Now again, with the 2 by 2 matrix, how do we take the determinant there? Well, we just cross multiply. So multiply down the diagonals, 4 times 5, minus the multiplication along the other diagonal, 2 times 0. And we multiply that with our component vector I. And so minus, doing the same thing with our next one. So negative 2 times 5 is negative 10, and then minus 3 times 0 is 0, times our component vector j, and lastly plus negative 2 times 2 gives us negative 4, minus 3 times 4, which is 12, times our component vector k. Okay, and so let's simplify this. So here we have 4 times 5, which is 20, minus 2 times 0, which is 0. So 20i, and negative 10 minus 0 is just negative 10. 2 negatives, we have plus 10j. And negative 4 minus 12, negative 16, so minus 16k. So there we have, as a linear combination of our unit vectors, is our cross product between u and v. 20i plus 10j minus 16k. So now let's take a look at B and C. Starting with B, so we want to find the cross product between V and U. Okay? So do we have to go through all this work again? Well, no, we don't. Knowing that we have U cross V, and also knowing that whenever you change the order of a cross product, you simply change the sign. So V cross U is equal to negative U cross V. Okay? Now, for a moment, why does that happen? Well, let's take a look at it. Without rewriting everything, if we were to change it to V cross U, all that would really change over here is we would change the order in the rows. We would have negative 2, 4, 0 on the bottom and 3, 2, 5 on top, which means through this next step, simply the top and bottom rows would be switched. It means our diagonals would be the same, but the order of subtraction would be reversed. And whenever you reverse an order of subtraction, like 5 minus 2 is positive 3, but 2 minus 5 is negative 3, you just change the sign. So the answer here is just going to be negative of our U cross V. So negative of 20i plus 10j minus 16k. Or negative 20i minus 10j plus 16k. So there's our cross product, V cross U. And lastly, we're going to find C, the cross product, V cross V, with itself. So again, from our properties, we know that V cross V, or the cross product between any vector and itself, just gives us the 0 vector, okay? Which is kind of hard to write as a linear combination between our unit vectors. So we'll just write it in component form. So 0 vector just having all components 0. So essentially this is our answer here. But before we go, let's again kind of review or remember, why is this equal to 0? Why does that make sense to us? Well, again, you can do the long work or do this work by hand and you'd end up with the 0 vector. But why? Well, again, if you had V cross V, that would mean that each row would be the components of V, 3, 2, and 5. And when we come down here to this next step, everything would be repeated, right? 2, 5 would be in both places, 3, 5 in both places, 3, 2 in both places. So the cross products, we call them that, would be the same. So you'd be tracking the same number from itself, always giving you 0. So these numbers, these coefficients in front, would all come out to 0, giving you the 0 vector. So thank you very much.